For question number 3, steam enter an adiabatic turbine at 5 megapascal at a temperature of 500 degrees Celsius, speed of 50 meter per second, lift at pressure of 50 kilopascal. The temperature of 150 degrees Celsius at a speed of 150 meter per second. If the power output of the turbine is in 5 megawatt, so these are the output of the turbine that rotate the shaft, so they give you electricity, let's say 5 megawatt. Determine the following properties: m dot, the mass flow rate of the steam to a turbine, and the isentropic process of a turbine in percentage. So first we have to do the analysis, okay, because there is W out, so the out is here, okay, so there is no effect of Q, so there is no Q. So what about the inlet? Okay, so the inlet and outlet here are remain the same. Why? Because here there is no effect of Q and W, so no here, so no effect of gravitational, so leave these things. Okay, so here no W, no Q, no gravitational effect. That's why the equation remain as that. Okay, right, so rearrange the equation, we got that's one. Okay, now let's move on into this okay, so state of superheated. So now we need to find H2, H1, V2 square and V1 square is given by the question. So E enter at 5 megapascal, so V1 5 megapascal, T1 500 degrees Celsius, V1 is what? 15 meters per second. Even though 5 megapascal is what? If you look into this, so 5 megapascal is what? 263.99. While here 500 degrees Celsius, yes, it's larger, so it's a superheated. So when it's superheated, so we will have to refer to the table, steam table of superheated. Okay, so where are 5 megapascal? So 5 megapascal. So 5 megapascal. Okay, so 5 megapascal. H is here, so 500 degrees Celsius, so 3433.8. Okay, so 500 pascal as 6.9759. Okay, and then the outlet lift at 50 kilopascal, so P2 50 kilopascal, temperature is 150 degrees Celsius, V2 is 150 meter per second. So what is the super state? So state of what? Here is already written superheated. So how we know that it is superheated? So go back into the table. Okay. So 50 kilopascal is what? 81.33. This one is what? 150. Yeah. So it's what? Yes, it is superheated. Okay. Right. In that case, we can find 50 kilopascal, 150 degrees Celsius. So go back into this steam table. So 0.05, 150. So it's what? 202780.1. Okay. Okay. Now we already know H1, S1, and H2. So we already know that this one 150, so 50, 150, so we can insert the value. This one have to be divided by 1000. Why? Because this one is unit kilo, this one is not yet the unit kilo. So in order to get kilo, divide by 1000. So this one is what? Megawatt. So it's megawatt. It should be kilo because it's kilo, this one is kilo, and this one is kilo. So 5000 equals to 5000 kilowatt. So everything is kilo now, so we can substitute and get the value of 9.03 kilogram per second. Because this is an isentropic process, so S2S equals to S1. Okay, so equivalence to, Okay, if the isotropic is percentage, so 6.759. Okay, so let's look into the effect of 50 kilopascal. Okay, so 50 kilopascal. Put it here. So 50 kilopascal is here. So 50 kilopascal, 50 here. So 7.5939. The question is what? 6.9. So it's between this one and this one. So it's a state of mixture. So in the state of mixture, in order to calculate the H2S, okay, this is for the isentropic process. So we got 6.979. So the VD value, because it's the same, 1.901. SFG 7.5939. So we got the value X 0.905. Put into this equation, you got 2426.8 kilojoule. Okay, now because remember this one, the question, because isentropic, in order to calculate this efficiency, we need to find the value of before and after. Okay, or sometimes we call it as the okay, so 5000 over the value of the one that we calculate using the if the effect of the isentropic efficiency. So put the value here. So H1 will remain the same, so just change the value to H2. So we got 9002.9. So by if this turbine is isentropic, okay, so isentropic means what? The state 2 is what? The state 2 is S2 equals to S1. Okay, so that's mean you got about 55.5% efficiency. Okay, so that's it for the question. I will explain later during the tutorial class. If you cannot answer, if you find difficulty on understanding the explanation from the video, then we will discuss later in the class. Right? Okay. Don't forget to ask the question if you don't understand.